Hello dear students, I welcome all of you to this another video on pointers in C. In this video, we are going to learn about a very interesting library function called malloc and also a library function called free. So these two functions will be introduced in this video. Basically, malloc function is a library function which is defined in a header file stdlib.h, standard library.h, and malloc function is used for creating variables dynamically. Now let's first of all understand what do you mean by creating variables on the fly or dynamically. So before we read the content what is written in this slide, let's see what does this mean. You usually declare an int variable as int, say int x, where we say x is a variable of type int stored in the memory. What we have done in this line, at this line is we have declared a variable with a name. Obviously, any student would say, come on, variable must have name. And indeed variable has a name. The name of the variable here is x. But what if we want to create an integer which can be stored in the memory which has no name? We want that some integer like 10 should be stored in the memory, but we are not interested in naming it. So for instance, if you see this declaration again, int x, what is the result of this? What happens due to this? In the memory, x is stored at some location and x will consume some bytes. If we assume that integer consumes 2 bytes, then 2 bytes will be occupied by x at some address, let us say 100, 101, and whatever is the integer, like if you say x should become 10, then 10 will be stored in these 2 bytes, isn't it? But the point is that these 2 bytes which are meant for storing integer is named as x. So we have a named variable here. What if we want that integer should be stored in 2 bytes in the memory at some address 100, 101. We want to store some integer, but we don't want to give it any name. That means we don't want to declare a variable. There you are. That's the big point. We don't want to declare any named variable like int x, but still we want to store an integer in the memory. Such a variable, such a place in the memory which stores an integer but has no name can be created by using malloc function. We say this type of variable creation is dynamic memory allocation. I repeat, this type of storing an integer in an unnamed variable is called dynamic memory allocation, and memory allocation is done by using malloc function. I hope you have understood what are we up to, why we are learning this chapter or this video. I hope you have understood that. To summarize it, we usually name the variables like int x, but we don't want to declare a variable now explicitly, but still we want to store an integer in the memory, but that integer variable will not have any name. All right then. Once we have understood the aim of this video, now let's see a few definitions. Now in the definition of malloc, it has been written that variables can be created dynamically using a library function named as malloc. Now malloc is a library function defined in stdlib.h, standard library.h. So make sure if you are using malloc function in your C program, you will have to write #include stdlib.h at the top of the program. By the way, malloc actually stands for memory allocation or memory allocate. Okay, let's understand this by understanding the grammar or syntax of malloc, how to write the malloc statement. I guess most of the students, on looking at the syntax of malloc for the first time, do not get into it, do not understand it properly. So don't worry, we are having an example. We are having an example coming up later on, which will clarify this grammar which I am discussing. But by the way, what is the grammar? You see, whenever you use malloc, here is the malloc function. The left hand side of malloc, that is equal to's left hand side, assignment operator's left hand side, has to be a pointer variable. Left hand side is a pointer variable and right hand side is a call to malloc function. Note that this is where we are calling malloc function. As malloc is a function, it will be definitely followed by bracket because it is a function call, and in the bracket we just write how much memory we need to allocate. That means we are requesting the operating system that please give us some amount of memory. Memory allocate will simply ask operating system that can you lend us, can you give some memory for use. In the bracket over here, you simply write how much memory you require. Like suppose you require 4 bytes. Then in the bracket over here, you can simply write 4. Look, you don't have to always write such a complex expression like size of data type that I have written. In case you need 8 bytes, you simply write 8 in the bracket. So 8 bytes will be allocated or reserved for our program. This is memory allocate. How much memory? 8 bytes. But writing 8 or 4 like that constant inside the bracket is not a good practice. We should make use of size of operator. As you see here in the malloc brackets, we should make use of size of operator. For example, suppose we have an intention of storing an integer. We want an integer in the memory. Then we should write this as size of, and this data type should be written as int. Then if size of an integer on our system is 2 bytes, then this will be automatically converted to 2. As an example, suppose you want to store a float. You need to allocate a float. You want a new float. Then you should write this as size of, and this data type should be written as float. And if on our system float consumes 4 bytes, then this will be automatically taken as 4. So that's a good practice of writing size of and which data type you want to allocate. Whether you want to allocate an integer or a float or a double is written over here. So what is the left hand side of the statement? We have a pointer variable. Right hand side is called to malloc, memory allocate, and how much memory you require is written in the bracket. Now something is written before malloc here in the bracket over here. Check this bracket. What is written is data type asterisk. Now actually this data type asterisk which is written in the bracket is meant for casting. This is meant for casting, or we call it as type casting. Now what's the problem is malloc will allocate the memory, and after allocating the memory, it will store the address of that memory which has been allocated in this pointer variable. Pointer variable stores address. So this pointer variable will store that address which has been allocated. But the address which is stored in the pointer variable is of void type. It is a void pointer. That means it will return pointer of nothing type. It's a void pointer. Malloc always returns address of void type. But what if we want this to be an integer? Then we will write here int pointer, or we want it to be a float, we'll write float pointer. Okay, I guess you have not understood much from this discussion. That's what happens to every beginner. But I promise you, trust me, that the example coming up will very clearly tell us what malloc does and what is the meaning of the grammar. Now check this. We have included stdio.h in our code and stdlib.h, both files. And main starts over here declaring two pointers, int asterisk p, float asterisk x. So definitely in the RAM, in the memory, there is a pointer called p and there is a pointer called x. Two pointers have been declared, and come again, p can point to an integer because it is an int pointer, and float pointer x can point to a float. But the big point over here you might observe is we have not declared any integer explicitly. We have not said something like int z is equal to 10. We have not created any named integer, or we have not created any named float like float q equal to 10.5, isn't it? What we have done is we have created pointers which can store address of integer and pointer which can store address of a float. Now comes the next line. We are calling malloc function over here. Check that. And in the bracket we have written size of int. Now size of int, assume that size of int is 2 on this system. Then this bracket will evaluate to 2. So malloc will allocate 2 bytes in the memory. So what will be done is the memory will be searched for a free place. And somewhere it will get free place. There it will reserve 2 bytes of memory. It's as if that part of the memory was empty, nothing was stored. So those 2 bytes will be allocated. But the allocation will be done at some address, isn't it? Let's say address at which the 2 bytes are allocated is 100, 101. This is where the 2 bytes are allocated, 100, 101. Then malloc will store literally value 100 in P. Look what P catches. P is written on the left hand side. What is P catching? P is catching the address of the allocated bytes, and address of the allocated bytes is 100, 101. So P has stored the value 100. In fact, P is a pointer now which points to that location 100. I guess you are understanding. So what is this bracket int pointer written here? I said in the grammar that malloc is such a function which will sincerely allocate the memory. It has done its work. It has allocated these 2 bytes. But it has to return the address, that is 100, and store it in P. But the address returned by malloc is always void pointer. It always returns address of void type. But on the left hand side we have written a pointer of type integer. Then we have to tell malloc, hello malloc, please don't return void pointer. Please don't return address of a void, because we have an intention of creating an integer. So we should write the typecast over here. The typecast is int pointer. All right, then if you have still not understood this, I prefer reading this statement in English. See, it's always a great practice to read mathematical expressions or even the C code in English. I read it as P, which is an int pointer, isn't it? We have declared it as int pointer. P, which is an int pointer. That is why we have written int pointer in the bracket. So P, which is an int pointer, should point to the newly allocated memory, and the memory allocated should be size of int. So first of all, malloc will do its work of allocating space of 2 bytes. Maybe it has allocated 2 bytes at location 100 and 101, and then malloc is going to return that address in P. And P here in the memory will now store address 100. So P points to that location. I guess you have followed it now, how to read this malloc statement. But big thing you observe, don't worry, we are coming to the end. This video is going to be a bit bigger because this is such an important concept. You can see that this place which I am marking is indeed an integer, because we have allocated space for an int. It's 2 bytes. So indeed it is an integer. It can store a value like 10, 20, any integer. But the big thing is there is no name to this variable. Generally, if we declare variables, we name them. But here we have created a variable of type int, place where we can store an integer. but it does not have a name. But we have a pointer. We have a pointer called p which points to that variable. So everybody knows from the basics that if you now write asterisk p anywhere in your program, then it means value to which that pointer points. I hope you are understanding. P is pointing to this space. Then asterisk P will mean value to which it points. So if I write asterisk P equal to 10, then 10 will get stored in that newly created integer. Look, we don't even have the name of the integer, but still we are able to use that place via pointer. We can use that place of 2 bytes. These 2 bytes can be referred through a pointer. We can write asterisk P, which many people call it as dereferencing a pointer. Asterisk P will take us to that particular location where we can fill up 10. Okay, great. But then it's a good programmer's practice, it's always a good practice that after you call malloc, once you call malloc, you should always check the status, whether malloc was successful or whether it was a failure. Now, malloc can be failure, malloc can fail if the memory is full. It is far from reality, This cannot happen most of the times. Memory will not become full. But who knows that you are requesting integer. You are requesting that I want to store a new integer. So please give me 2 bytes. And there is absolutely no place in the memory. Memory is full. In that case, malloc will be a failure. In such case, malloc returns a special value called null and it stores that value null in P. So if malloc is unsuccessful, if it doesn't get any place in the memory, it cannot allocate any bytes. So it will store a special value. That special value is null. And this null is a reserved word which is always written in capital letters. It's a reserved word and it is defined in stdio.h. This reserved word is in this header file. So what I was telling is it is very good programming practice that after you call malloc, you check whether malloc was successful or not. The way to do it is you just check what is value of p. If p is null, that means malloc has returned a null value and stored it in P. So malloc was unsuccessful in allocating 2 bytes for an integer. So if P is null, you can print an error, cannot allocate memory, and you can return. You can stop the program. You see, return 0 will stop main instantly, isn't it? Because return marks the end of the function and main is a function. So return 0 is going to end the function. Basically, it is responsibility of the programmer that whenever he or she calls malloc, they should always check whether the allocation was done or not. And if the allocation was not done, they should print the error. And come on, you tell me if there is insufficient memory. If memory is full, then what's the point in continuing main? What's the point in continuing the program? So we can halt the program. Many programmers even call over here a special function called exit. You might have heard about it. Exit 1. Exit will abruptly end the program or the process. It's just like we terminate a process by going to task manager. Exit will terminate the process itself. But return 0 is also effective. Return 0 can also terminate main. All right then. What has happened till now? Till now, we have allocated memory for integer. So 2 bytes have got allocated somewhere in the memory. Maybe allocation has been done at 100, 101, and P, the pointer P, which is waiting on the left hand side, now stores 100 and points over here. And this if is false because we are successful, memory has been allocated. Now the next line. Let's try to print the value of the pointer. Value of the pointer means we are printing address, and addresses are printed always in %u format, unsigned. It is unsigned integer. So P printed over here will be 100. So we can know at which place is the memory allocated by just printing the value of P. Now comes the most interesting part. What does asterisk P equal to 10 mean? What does this mean? Value to which P points, this place should store 10. Look, We have used this integer even if it does not have a name. Very interesting, isn't it? And we can also then print that value of the integer %d, and if you print asterisk p, it is going to print the value to which p points. That value is 10. All right, then the next thing is free p. Now free is also a library function. It's a library function defined in the file stdlib.h. Free is exactly opposite of malloc. Malloc allocates the memory and free deallocates the memory. Look, it is so easy to use free. We have written free. In the bracket, we have written name of the pointer. So free p is read as free that memory to which p points. Free that memory to which p points. And p points to 2 bytes, isn't it? Memory of or a block of 2 bytes. Then if you call free p, then the memory that has been allocated where 10 is stored will be released, will be returned. It is like, our program is announcing that we don't want that memory anymore. Yes, short while back, we asked for that memory using malloc. Now we are saying we don't need this memory, so better take it back. So this memory is marked as free. This memory is free now. These 2 bytes are free. So operating system can store something else over here if it needs to. So that's how you allocate and deallocate the space, by creating new variables using malloc and by releasing the variables, by returning the variables using free. Something interesting now over here. Look, we have freed this memory, isn't it? But what about P? Now, many beginners, many students feel that because we have freed this memory is erased. And P also will not contain 100 now. P will be empty and it will not point to this location anymore because we have released that memory, which is absolutely false. This is very surprising. P was pointing to this memory, 2 bytes, yes, and we have freed it. We have released it, but still P will store 100. Very surprising. P doesn't know that memory is released. Rather, we have used free P, but P will continue to point to 100. It will continue to point to that 2 locations. You will agree this is senseless. P is pointing to a location 100 and we know that location has been released. Such a pointer in programming is called dangling pointer. Dangling pointer. A pointer which is pointing to a unused memory, which is of no use to us, is known as a dangling pointer. I hope you are continuing the video, you are concentrating in this video because you are getting lot of new terms. Believe me, in GATE exam, lots of questions have been asked on dangling pointers, malloc, free and all that. Okay, but you don't have to worry about this. We will be stretching this point in the next videos about dangling pointer. In fact, we have got an example also in a GATE question about dangling pointer. All right then. Let's read a few more lines. X is equal to float pointer, malloc, size of float. You recall that above in the program, we have declared X as a float pointer. So what does this line do? You can read it in English like this. X, which is a float pointer, will point to newly allocated memory. And how much memory will be allocated? Exactly that much memory which is required for storing one float, size of float. Now imagine on our system, 4 bytes are needed to store a float. So 4 consecutive bytes will be allocated and you can store one float in this. Maybe the allotment has been done at location 200. So this last location will be 203. This entire block is for storing one float. But then what will malloc do? Malloc will simply return the address and store it in X. So X is a pointer which will store the base address of the float. X is now pointing to 200. You also know why we have written the float pointer in the bracket here. This is meant for casting or typecasting. You further know that after call to malloc, it is a very good habit to check for success or failure. If this variable x, if this x is null, if it is not storing any meaningful address like 200, if it is storing a value like null, then memory was not at all allocated and you can return 0 and stop the program. Otherwise, if the memory was allocated, you may either print the value of the pointer. Now you see, if you print the value of x here, the output will be 200. That shows that the float was allocated at address 200. You can also store some float by using dereferencing. Asterisk x will mean value to which x points, isn't it? This place. So this place is going to now store 10.5. Look, we didn't even have name to this float variable, but we are successful in storing a float via or using the pointer x. We have further printed the float in %f format. We have printed asterisk x, and asterisk x will be the value to which x points, which is 10.5. What will free x do? How do you read free x? Free the memory to which x points. Free the memory to which x points, and x points to a block of 4 bytes. So all these 4 bytes will be released. It's like we are announcing that we no more need these 4 bytes. We are not interested in this value either. So how free deallocates the space, how malloc allocates the space, I hope you have understood. The output of this program will be 100, assuming integer was allocated at 100. This was the value of integer, and value of x is 200, assuming that the float was allocated at 200, and this is the value of float. In detail, more and more examples on malloc and free are coming up in next videos. Thank you very much.